Hello everybody and welcome back. Root Beer here as always with question number 6 in this video on our 2016 Euclid contest. So let's see what we've got with question 6. Two parts here. Light bulb and written as we've seen for the last couple questions. And what have we got for A part? What is the smallest positive integer x for which 1 over 32 is equal to x over 10 to the y for some positive integer y? Okay. So a positive integer x and a positive integer y. So fractions, I mean, they're fine, but what we can do is we can actually sort of rearrange these, multiply by 10y on both sides, and multiply by 32 on both sides. And so what we've got is 10 to the y is equal to 32x. Now the bigger we make y, 32 stays the same, the bigger we make x. So what's the smallest y that is a multiple of 32? Okay, well, remember, 10 is 2 times 5. And 32 is really 2 to the 5. Okay, so what have we got? Well, we need, we can expand this out. 2 to the y times 5 to the y, 2 to the 5 times x. Now, if this really is, on the left-hand side, a multiple of 32, I can divide both sides by 2 to the 5. I'm going to divide by 32. And this gives me an equation for x. But we need y to be greater than or equal to 5. Otherwise, we're dividing by 2 at least, and x wouldn't be an integer. So, well, the bigger we make y, the bigger we make x. We can see y should be 5. So 10 to the 5 should be 32 times x. Okay, so x should be 100,000 divided by 32. And you can grab your calculator to work that out, or you could say, well, it's going to be 5 to the 5, and that should be 3,125. Either way, you're going to be fine there. So we can get x is 3,125, and we wanted the smallest value of x. That's the one that's going to do it for us. 5 to the power of 5. Now, it's a light bulb, so we just need to put that, but we do have our reasoning just in case we've made a mistake, just in case there's some error in our calculation, or we just put the wrong number. We've still shown how we got our answer here. All right, B. Determine all possible values for the area of a right-angled triangle with one side length equal to 60, just 60. With the property that its side lengths form an arithmetic sequence. And if you don't know what an arithmetic sequence is, they tell you down below. Basically, all terms in your sequence, so in this case, all 3 sides of our triangle, have to have a common difference. So there's sort of 2 triangles we could really make, I guess. We know that for a right-angled triangle, the hypotenuse is the longest side. Okay? Either 60 is here, on the hypotenuse, in which case the other 2 lengths are smaller by some common difference. So the previous term, we might call it 60 minus d, and then subtract that d again to get the smallest side length. And then these 3 terms in order make an arithmetic sequence. Or we could have 60 on one of the sides. So I might say, 2 possibilities. So 60 could be on one of the sides. Okay. But, well, if 60 is on the... I suppose we have 3 possible triangles almost, because while 60 can be on the side, 60 might not be the shortest of the sides. So we could have 60 plus some common difference, and then 60 plus 2d as the hypotenuse. That's the longest side. Or we could have 60, but it's the middle value. Okay? So these are 3 possible right-angled triangles, and they're the only possibilities. So now it's on us just to explore each of these possibilities. We can get a single equation using the Pythagorean theorem. A squared plus b squared equals c squared, and we'll have one equation, so we'll just solve for d. So I suspect each 3 of these triangles will yield 1, maybe 2, just because there are some quadratic things to consider, possible answer. Okay? That's all we need to work out. So we can get right to it. They didn't require the side lengths had to be integers or anything, right? Nope, not at all. And then once we have these triangles, we'll find their areas using base times height, 1/2 base times height. Okay, so I might give these cases numbers, just so it's very clear to whoever's reading what's going on. So we'll do case number 1. 60 is the longest side. Okay, well then 60 squared is 60 minus d squared plus 60 minus 2d squared. So 60 squared, I'm just going to leave them as 60 squareds. I'll expand them out if I need them. Minus 120d plus d squared plus 60 squared minus 2 times 2 times 60 would be 240d plus 4d squared. Alright, so 60 squared and a 60 squared will cancel. All we'll be left with 0 is 60 squared. I'm going to expand it out to 3,600 minus 360d plus 5d squared. I can divide by 5 everywhere. So we'll get 0 is equal to 720 minus 72d plus d squared. And now we ask, alright, can I work out answers there? Can you factor it? Can we do some sort of quadratic formula? 72 plus or minus 72 squared minus 4 times 720 all over 2. Alright, 72 squared minus 4 times 720. Ooh, that's actually, so that's 23 squared, I think. No, it couldn't be 23 squared. It's something. Just under 50. Is that 48 squared? I feel like it's 48 squared. Well, actually, I've got my calculator. I'll just press the square root button. Yeah, 48 squared. So d is 72 plus or minus 48 all over 2. 36 plus or minus 24. So 12 or 60. So d is 12 or 60. So what triangles do we actually get? Well, we could get 60, 60 minus d, 0, and then minus 60. Or 60, 60 minus 12, and then 60 minus 24. And that would work. And if you want to, you can double check. But this is a 3, 4, 5 triangle. Just multiply by 12. So that one works. And we can find its area. Well, we'll do that while we're here. So 1/2 base times height. Making fair use of the calculator here. So we get 864. So far we've got one. Let's see. What do we got? Case 2. Did I number that first one as case 1? I did. Okay. So we have 60. This one wasn't 60 in the middle. It was 60 as the smallest. And I feel like we're going to get a very, very similar sort of thing. I think D might be either negative... I feel like D being negative 60 will be an answer here. But what can we do here? So, let's see. 60 plus 2D squared is equal to 60 plus D squared plus 60 squared. We'll get 60 squared plus 240D plus 4D squared is equal to 60 squared plus 120D plus D squared plus 60 squared. 60 squareds will cancel out. You can bring everything over to one side, so 3D squareds plus 120D minus 3600. Divide both sides by 3. And since I'm pretty sure D being equal to negative 60 will work, we could factor this. I'm going to say D plus 60, and then D minus 20 equal to 0, because then I'd get the plus 40. And 60 times 20 is 1200. So d negative 60 or 20. Of course, we could use the quadratic formula again if we wanted to. But we get 60, 0, minus 60. Of course, that's not a real triangle. Or 60, 80, 100. This is another 3, 4, 5 triangle. 3 times 20, 4 times 20, 5 times 20. So this will work. Area, 1/2 base times height. And so we get 2,400? I feel like it's 2,400. Yep. Alright, so there's 2 triangles we've got. And now, case 3, and this was where 60 is one of the shorter sides, but it's not the shortest side. So I'll get 60 plus d squared is 60 squared plus 60 minus d squared. 60 squared plus 120d plus d squared is equal to 60 squared plus 60 squared minus 120d plus d squared. 2 of the 60 squareds and the d squareds will cancel out. 240d is 360. Divide by, at least the 10 on both sides, but divide by the 240 on both sides, and we'll get d is 15. And that'll lead us to another triangle. So 60, 75, and 45. And wouldn't you know it, it's another 3, 4, 5 triangle. That actually makes sense because if you're going to have an arithmetic sequence, 3, 4, and 5 really are the only Pythagorean triple I can think of where the sides are an arithmetic sequence. Kind of cool. So this one also works. 15 times 3, 4 times 15, and 15 times 5. And the area, 1/2 base times height. So 30 times 45 should be 1350. You can double check on a calculator. There we go. So possible areas, just to sum up, are 1350, 200, it was 864, I think? 864. And that's all we were asked for. What are the possible areas? Determine all possible values for the area. There we go. Okay. There were a couple what we call degenerate triangles, the 60s, 0, minus 60s. I didn't see one coming, but then after seeing that, I spotted it. I was able to factor the second one. But overall, I would say it's fairly straightforward as long as we understand what an arithmetic sequence is. The right angle triangles, so Pythagorean theorem guides the way. Okay, so that was question number 6. On we go to question number 7, and I will see you for that next time.